We can begin today's session. So just as I've mentioned, it's all about showing you like where you can get the guides for each and everything that you need. So far we've looked at computer vision, which is the main item on for you learning deep learning. We've got transformer-based models and RNN that we haven't looked at practically, but that basically will come up next. As I had mentioned earlier before, I said that you should create a Kaggle account. So it's on Kaggle where you'll get all the best resources that you would need to ace when it comes to data science, like deep learning problems. So our first resource will be kaggle.com. Okay, so this is where you should start up from. What I will say is you're not supposed to partake any competitions because you've got lots of competitions that usually do happen over here. They are there to help you improve your skills, but definitely there are people outside there who are really great and have got all the resources they need to like be top of this league. But once you are good, you can join these competitions and try your best to be at the top. Okay, so the first thing you need to look at is, once I'm at Kaggle, what am I trying to solve? Let's say I'm in, for example, for me, I'm in finance. I can search for finance data sets and see what people have created. So if I just search for finance and click search, you'll get all these different results that you have over there. And then to make things interesting, you can filter by the last 90 days results. And then you can filter either by notebooks, dataset, topic, comments, competition, and models. So first of all, you can check models. Like you can see over here, you've got different models. You've got the Quen 3 4B Finance. You've got the Halugate Sentinel Finance. So all these are the finance models. You've got different notebooks. So finance, day one, agent architecture. So finance researcher researches finance and fintech news and trends. You've got personal finance and lifestyle system, finance trend analysis and prediction. So basically anything that you would need. So finance and debt risk intelligence agent, finance and economic data exploration. So this is a wide search, but at least it gives you what you need. Okay, so let's say, for example, the best type of task that we could work with will be computer vision, right? Because this is basically what we are currently learning and what we've learned. So this is computer vision. What you need to do is you need to filter by what you have for the last 90 days. So for you to get the latest results, you can see, for example, over here, we've got this notebook that was created 1 month ago with 34 likes. You can just open that, Introduction to Computer Vision, and see what has been created over here. So this is basically something that is to help you at least upskill even more. So you can see it has got lots of data sets. So you've got brain MRI images for brain tumors. You've got celeb data set. So this is celeb faces data set. You've got dead fruits data set, dry beans data set. You can actually click see all and see all the data sets that you have. So rice images, pumpkin, Picasso, Picasso dataset, grapevine, face mask, dry bean, date, celeb faces, and all that. And on this notebook, you've got simply something like a tutorial showing you like different things that you need to learn under computer vision. And the good thing is this is latest information and it includes things that mostly we've been learning in class. So for example, you see this chart. If we go to our notes, uh, should be somewhere here. Let me see if it's there. No, I believe I shared this as a notebook. Yeah, it should be a notebook on the first practical class that we did. So you had all these information in there, but over here you can see there is some extra stuff that we did not do in that class. But how do you get this info? You only get this if you search for it online. So for example, you can see they are discussing all the model architectures that we've looked at. I've taught you about the AlexNet, the VGGNet, the GoogleNet, and the ResNet. And then we've implemented the EfficientNet practically as well, like showing you how you can instantiate this model and doing transfer learning to it. So for example, you can see over here, they've got a different definition to transfer learning, okay? And they're showing you like how even transfer learning works, but in a simpler way over here as well. So this is basically where you're supposed to get all these resources that you have. They're even explaining things that you've learned in the basic machine learning class. So let's say from here there is these data sets that we've seen over here, like from the input. So you've got rice images. If you wanted to create a model that is to predict rice diseases, so what you can do is you could search for rice. I'll just click search. I'll say the last 90 days. We can check notebooks. So this is rice quality. This is something I'm working on, but it's still in private. I can show you that because I'm fitting a large language model for that. But you can see like you've got rice leaf CNN for 3-class disease. If we maybe sort this by date, you'll get to see like the most recent notebooks that we have. Let me sort by relevance because I believe in terms of relevance, it will give the rice details. So we've got rice CNN PyTorch, rice classification with 99% accuracy. So actually you can open this and see like what did this guy implement when he was building this rice model. So you can see this is the rice classification notebook. These are the different rices that we have. So this is the abstract. So rice, which is among the most widely produced grain products worldwide, has many generic varieties. So these varieties are separated from each other due to some features. So these are usually features such as texture, shape, and color. With these features that distinguish rice varieties, it's possible to classify and evaluate the quality of seeds. In this study, so you've got the names, which are 5 different varieties of rice, often grown in Turkey, were used. So a total of 75,000 grain images, 15,000 of each of these varieties. So that's what you have. And then you've got the libraries importation over here. So just TensorFlow, which is good. You can see the conv2d layer, max pooling, dense, flatten, and batch normalization, and dropout that we've basically been using in class. Nothing new has been used over here. Then the dataset is imported. Then you've got the txt removed. And then over here, you've got this is just markdown formatting. You've got some visualization on the rices. So you can see you've got bounding boxes created. So these are not the normal shape that we usually have, but the bounding boxes are circular in color. So you can see the different rice grains that are there. And basically this is, I believe this is image that has already been pre-processed. And then you can see like this data augmented as well. This is basically data augmentation, because if you look at this image, it's basically the same but in different angles. Okay, and then over here it's just some basic markdown, and then the images as well, just seeing like the different rice types that are there. Once that has been done, you've got a summary like showing you the different rices that are there and showing like the lengths and all that. Then down here we've got the number of classes per image, just some basic pre-processing. I'll scroll down to the model part. Yeah, this is the model part. So you've got your data preparation. So this is train, yeah, this is validation, this is test, and then you've got your model. So you've got your CNN base being equal to sequential. So this is basically where they're preparing the model. So they add a conv2d layer, a max pooling layer, then the batch normalization, conv2d, max pooling. They flatten the CNN model, and then they do the processing of the outputs, and then they train the model. And after the model has been trained, you get an accuracy of 99%. So it's just something that's simple. And over here, you get the classification report showing you that no class is suffering in terms of recall and precision. And then I believe they train another model, yeah, and make predictions, and we get our results. So that's basically how you explore things that are being done online, and you learn from what other people are doing. Apart from that, what else could we check? You could check the datasets part, search for datasets that you will need. So you can see you've got all datasets: computer science, education, classification, computer vision. So you can select computer vision, what we've currently been working on, and you can filter by hotness, most votes, new datasets that you might have. So you can see we've got vehicles, open images dataset, we've got fruit freshness classification, license plate detection. So basically any dataset that you can think of, okay? And apart from that, you've got the models part over here. So as I've been training you, I've been telling you that you don't have to start training from scratch. That's a lot of work that you don't really need to do. You need to start your training for the models from a model that has already been pre-trained. So you can see over here, you've got the models part, you've got all models listed. So you can check the trending models that are there. For example, the Quent 3 TTS is a model that came out recently. And then you can filter by task. So you can see you've got text generation, you've got image classification, classification object detection. So we can go maybe, for example, with image classification and apply. If we click image classification, you can see we are getting the Gamma 3, EfficientNet. If you open the EfficientNet model, over here you'll see all the different codes that have been created using EfficientNet. So I believe sorting it by recently created will be best. So you can see like the most recently created model was 2 months ago, but you've got other models as well. So for example, this one, EfficientNet B3, just fold 4, infer from only images with balanced mix-up, PyTorch training baseline. So this is a baseline on how you can fit these EfficientNet models. You've scroll down and check and check and check, and you can spot different notebooks that might help you in different tasks that you might be doing. If we go back to our pre-trained models and we scroll down again, you can see we've got EfficientNet V2. So different models, ResNet 50, ResNet V1. You've got these ultralight yellow V8. You've got the DenseNet model, RetinaNet, ResNet V2, AY, MobileNet V3. You've got VDET. So all different models that you can work with. So there are lots of things that you can get out here, but you'll need to explore for you to get them. So for example, you can see you've got this disease classification model over here. So this is the AgriPredict disease classification model. If you look at the details for this model, it's a TensorFlow model, and it's a fine-grained image classification model for crop disease classification. So if you are working on a crop disease classification model, rather than training your model from scratch, you can start from here. So you can see, like, you can start from the outputs, like what is the model doing? So it's determining healthy tomatoes, and it's all about tomatoes over here. Like, yeah, you can see you've got tomatoes mostly, you've got soy, you've got maize. Yeah, so just a few diseases. So it basically means that this model was fitted mainly for these. So, yeah, so you can see 14 classes. You just have to read the details and know, like, what is this model doing. We can go back, change the filter over here and see, like, if we are dealing with text generation, because we looked at the RNN models, we saw that they are mostly for text generation, text classification, and all that. If we click apply, what do we get? So over here, we will mostly get LLMs. So for example, the Gemma, Polygamma, Volt Gamma, Mistral, the T5. T5 is just it's just the best improvement that you get from the RNN models, like it's the improvement that we had after LSTM. Because if you check over here, for example, I haven't shown you that, but this is T5 versus, let's say, LSTM. Yeah, you can see. So T5 text-to-text transformer and LSTM long-term short-term memory. So T5 is a modern transformer-based model optimized for complex, large-scale NLP tasks using parallel processing, while LSTM is a sequential neural network designed to handle long-term dependency dataset. So these are the key differences. So they do the same work, the T5 and the LSTM model, but basically like the results will be better for the T5, which is a transformer based model as compared to the LSTM. And the reason as to why LSTM will be better is because of this context thing that we have over here. We saw the LSTM model was using the TANH gates, the sequential gates, but for transformer models, they've got something we call self-attention. Okay. That's what we have. Let's have a look at other things. You can check like the data type that you are dealing with, because most probably most of the things that you will be doing will be new. If we, let me clear all. If we check the data type, you can see we've got different data set. If you're dealing with tabular data, you can search. You can see you've got tab PFN, OpenPI LLM. If you are working with audio data, these are the models that you can work with video data, Wave to Vec 2. So this is a great model. And then if you are working with video data, these are the models that you can work with the video data. So for example, Qwen3 VL. And actually you can sort these by most votes, see which model is used most of the time. You can check another type of data, for example, text data. So most for text data, you can see it's all about LLMs. Image data, LLMs. So nothing is changing. So we are transitioning from the base models that we've been having to LLM based models. So everything that I've been showing you is working, but for you to be at the top, they're at the top where you are just better than everyone. You have to learn LLMs, and that's the reason as to why I've shown them over here. Another place you will get all these info, like just a little bit of what I'm showing you. Kaggle has got the best source of information you will need, basically concerning any project that you would like to start. Another place that you will check will be the Zindi platform, which is African based, but over here you'd have to dig in deeper. For example, if we look at completed competition, let's say this one, lands and surveys plot automation. So this is a computer vision task. If you check the chat part over here, so this is the only weakness that you'll have on this platform. You have to go and search for this info in the chat place. So this was the guy at position number 1. You can see they shared their solution. For you to see like what they did to get here, you'd have to head over to GitHub. So click this Git repo or just read these short text that they've shown over here on what they need or what they did. But over here you can see like the GitHub repo with everything fully set up. Like you can download the code and yeah, get a winning solution. So that's basically should be it for today. Just showing you like where you should start off if you are trying to create a new model or you're trying to come up with something new that you can work with. This is basically what you do. I will suggest you get all info that you need from Kaggle. If you're not able to get the info that you need from Kaggle, just now do the normal Google search. But I will assure you, in normal circumstances, everything that you will need is available on Kaggle. I would like you to maybe ask questions if you've got any. Any questions? Okay, if you've got no questions, then that should be it for today. Just a quick short session showing you like where you're supposed to get info that will help you grow in your computer vision task or deep learning task. So tomorrow we will start working on these computer vision projects. So we might only work on the business understanding up to data preparation part before we do the modeling, because I'll need to take you through this code slow by slow for you to understand each and everything that we are doing, because we are working with real data over here. Yes, Ian?
Just one question.
Yeah, you can ask.
Uh, If you're building something new,
Mm-hmm.
then and you're using Kaggle,
Yeah.
how will you know that you're working with something that is accurate? Does it have like a score?
No, it doesn't have to be accurate. You just have to do your own internal evaluation. Like what you need is just a skeleton of like how you're supposed to structure the project. Because from experience, the hardest thing that you'll work on when when you are in this field is starting, like having a structure where you can start. That's the most hardest thing that usually most programmers do have. But once you've got something that's working, then improving it will be quite easy. You don't have to worry about the accuracy. You just need to get something that's, first of all, working. Does that make sense? Because, for example, if you are working on a competition, right? Let's say you are over here on Zindi. If you look at this competition, the AI telco troubleshooting challenge, I'm not sure, like I don't know the date when this competition started. I believe it started in December. Yeah, it started in December. So you had 2 months to figure out like how you're supposed to solve this. So so you can see, for example, over here they're telling you that can you fine tune a reasoning LLM to help engineers solve network faults. So enhance accuracy of Qwen 332B. So this is what you are working with, right? Have you ever interacted with the Qwen 332B model?
Not yet.
Yeah, you've never interacted with it, so you don't know a thing about that model, right? So but how do you start? Do you go to the Qwen 3 documentation site? So if you check like the Qwen 3 documentation site, this is basically what you have. And the truth is, I'll tell you, if you try run this on if you try run this on your normal machine, this code will not work, because it's not optimized the documentations are not optimized. They just give you some rough work. And over here you don't have any code showing you like how you're supposed to fine tune these models. So they are only showing you like the code that you're supposed to run inference on. But if you are to fine tune this model, first of all you would come copy it. So let's say, for example, I'd copy this name over here, Qwen 332B. I'd head over to Kaggle. Maybe I can click on home, and then I'd search like Qwen 332B. I'll click enter, and then you can filter by the last 90 days because you want the best notebooks that are there, and then you can filter by notebooks. So you can see over here you've got the AIMO Qwen 332B model, you've got the child LM Qwen 14B model. So you've got all these different notebooks showing you like how you're supposed to fine tune this model. So the most relevant one for you will be this notebook that was created 2 months ago, because you can see this is exactly the model that you are working with. Or maybe you can check this second one over here, because you can see the model that you are working with is the same one over here, and this has got even more votes. So if you run this, you'd see like summary. This notebooks aims to serve as a quick introduction to building a submission for this competition. It is a refactored version of the notebook that won the early sharing prize. Okay. So dependencies and accelerators. So you can see they are showing you basically how you're supposed to set up this notebook. So imports, constants, like setting your constants, loading the model. So you're loading the Qwen 332B model, utility function showing you like what you're supposed to set, batch processing function, inference, setup for Kaggle, that the setup for Kaggle, and references. So that's basically the first notebook. We can go back. Let me go back. Then you can check the first notebook that has 75 votes, and you can see this is another notebook that you can start with, right? Because it has got everything fully set up, and it's something that you are working. And actually, you can see over here, for example, this is the prompt that this is a notebook that is being used for training. I want you to confirm that what we have over here is actually similar to what we are dealing with over here. So this is the prompt, like please use chain reasoning to put the answer in. You can see boxed, right? So this is boxed. If we come back to this competition that we have over here, I'll click Control Find, I'll paste Control V. So in text, in the yellow box indicates a possible output of LLM, including the selected root cause included in dash dash box. Does this match what is in this notebook?
Yeah.
It matches everything that is in that notebook. So basically, Kaggle is there to give you like a head start. From there, you'll have to now add in your own thinking and improve what this guy has already done over here. Because, for example, you can see obviously in his code, he's adding comments that will guide you in each and everything that he did, so that when it comes to you updating your code to fully do the tasks that you want it to do, it will just basically be easier for you. You just don't have to start from scratch because someone has already built something that's working. So the only thing that you'll need to do is you'll need to change like your data input part. So for example, this is library loading, this is LLM model loading, and then there should be a data. This is the tokenizer, this is the prompt. We've got temporary file, yeah. We've got the prompt creation part, like the input creation part. Trying to locate the data loading part. They have correct answers. This is your question. So your question will basically be these questions that you have in your train file over here. And then yeah, you just have to, yeah, so this is where you are reading in the CSV file. If we check this is the references.csv file. If we check references.csv file, you've got your question over here, which is a long question, and then you've got your answer. I can't see where the answer is at. Let me just go to the input. Checking. So you've got the ID, you've got the problem, and then you've got the answer, an integer from 0 to 999. And then if we check like these data that we have over here, you've got, let's check like the Hugging Face version, because I believe it's easier over here. So you've got the train data set. So you can see we don't have an ID column, but we've got the question and we've got the answer. These two data sets match. So the only thing that's missing is the ID column. So what will make you not start from these as your template and just go ahead and create something from scratch? You should start from this and then improve from there. Now, do I make sense now in terms of like how you're supposed to start your project? So starting is the hardest thing. And if you compare what the documentations have given you over here, it will be hard for you to start using this documentation as compared to you running something that someone has already run online before.
Yeah,
Yeah.
it saves time.
Yeah, it saves you time, and then at least you can learn from people who are already good in these industry, so you don't have to do everything from scratch. Yeah, so that should be it. Any other question? Okay, if you've got no other question, that's the thing that I wanted to show you mainly for today. I'll stop the class.